The Biomechanics Honors video series. Today what we're going to look at is the mechanical analysis of running. We're going to look at intervention strategies to correct movement faults and how to report on some of these. So in order for you to become effective in this specific prac, there are a couple of things that you'll need. One is the Canova video analysis software. Okay. You will also need the prac data sheet, which is titled Gait Analysis and Intervention Strategies. Basically, it's going to tell you and take you through the objectives and the methodology of this specific prac. It'll take you through how you should set your video up and all the things that you should take into considerations when you're assessing and analyzing someone on the treadmill. How to record your data and what to look for, and then finally how to present your results and some review questions. You'll also need the analysis component, which will take you through exactly what it is that you are assessing and analyzing and what the specific normal ranges are and the specific treatment modalities for each of the abnormalities that we're going to be looking at in terms of our analysis. So it's going to be quite in depth and quite a lot of things to look at. And finally, any analysis is useless unless you are trying to put some kind of intervention together. How are you going to correct these movement faults? So I've put some recommendations in terms of treatment modalities together for specifically hip flexors, your hip extensors, muscles around the hip joint, knee joint and ankle joint, and how you should go about treating them in your intervention strategy. So you'll need that sheet. You'll also need your template sheet where you'll be capturing each component of your analysis and writing up on it. And then finally you will have some general comments and recommendations going forward together with your training program. Okay, so how do we go about doing this analysis? So first things first, start up the Canova application. You can either download this or you can do all of this in the lab. As it's already pre-installed, you will go to where you need to ultimately open your file. In this case, I've already taken a video of Dion running, and you'll have this kind of a setup. There's a couple of things that you'll need to just get familiar with. On your mouse, your scroller, if you scroll up, you'll notice that the video will play forward, and if you scroll down, it will play backwards. So that becomes quite useful if we trying to just go frame by frame. If you hit Control and you scroll, scroll upwards, you'll be able to zoom in a little bit, which is a little bit better for our analysis. And if you hit Control and scroll downwards, you'll zoom out. So we'll be in this kind of a zoom, approximately 170, 180% of the original video. Then there's a couple of options here that we can use for our specific analysis. Okay, so let's start step by step. One of the first things that I'm going to start on the right side of our particular athlete, and I'll go straight to where his heel hits the ground, and I'm going to assess a couple of things on the right side, typically working from the ground going upwards. So one of the first things I just quickly want to check is I'll use this line option, and you'll see it just changes the screen slightly. I'll zoom in again a little bit more, and I'll draw a straight line down from the middle of the heel. What I'm trying to check is where his heel strikes relative to where his mid glute is, and how his heel will recover during the swing phase. Does it rotate out to the side laterally, or does it rotate medially as he's trying to go through his swing phase? So you can already see here that there's some slight hip shift relative to where the heel strikes. So his hip is a little bit lateral, which most likely indicates some hip stability issues, right? Because for good efficiency, these should be optimally aligned. So now if I simply scroll the mouse forward, I'm going to go to where he's in mid-swing and as the opposite leg tends to strike. So what you'll see here is I'll draw another line, and again what I'm trying to check here is relative to where his mid heel is, how does that compare to where his mid glute is. So you can see here now there's some kind of medial rotation of the lower leg relative to the hip. So again, that's something in terms of the actual muscular, the functional anatomy of the hip and knee joint that may be playing a role here in terms of how his leg tends to recover. So when it comes to treatment, there might be some elements in terms of hamstring musculature, knee musculature that we want to look at, adductors, so on and so forth. Okay, so what I would do now is I would screen capture this and save it on a Word document, or what I typically do is I'll just open up like a PowerPoint, because it's easier to copy and paste things in there. So I'm just going to show you one, and then you guys can do the same thing sometime again. So just press the print screen option on your computer. I would open excuse me, PowerPoint, and just wait for that to run. And once it's up, I'll just click Control or press Control V. If it doesn't work, just go press it again. Sometimes when you run it the first time, it doesn't quite want to. And then you can see the screen capture appears. I'm just going to crop it just so that I have the picture of interest. And I'll leave this here for now because I'm going to put that in my report a little bit later on. Okay, then I can go and delete these, because there's a couple of other things that I want to measure. I'm going to scroll a little bit backwards to when his heel of the right foot has hit and he's loading it. So here I want to look at his calcaneal angle as he has loaded it. So to do that, I'm going to use this angle option, and you'll see once I draw it, my goal is to have the axis of rotation of this goniometer, this kind of digital goniometer. I'm going to put that on the middle of the calcaneus so I can zoom in. And what I'll also do is I'll just change this color a bit to make it a little bit more clear. So I'll use yellow as the option. I'll apply that, and you can see that makes it a lot clearer to see. So when I zoom in, I want this middle portion and the middle of the calcaneus, or middle of the Achilles. I'll use the bottom portion to align with the middle of the calcaneus, and then this movable arm I'll have middle of the knee. Okay, ideally we would want this angle to be 180 degrees, and normal range of acceptability is give or take about 5 degrees, 5 to 6 degrees. So this would still be acceptable if it was around about 174. So you can see here this is a slight amount of calcaneal eversion that goes beyond the normal limits, meaning that his subtalar joint is definitely pronating, and it's allowing for too much motion and mobility in his ankle joint. So what that ultimately means is that there's some aspects in terms of his posterior tibialis, or even in terms of his peroneals, that we'll start to investigate a little bit further when it comes to the actual treatment option. Okay, so again I would screen capture this, so I'm just going to do it one more time. I will print screen, I'll go to this, I will paste it as a picture, format it, crop it, and that means I can use it in my report when I'm talking about his right leg calcaneal eversion. Okay, so you can see I'm just going to build up a library of pictures as we go along with the specific analysis. I'm going to zoom back out a little bit, and then I will delete that again. Okay, so the next aspect that I'll do is I'll play forward a little bit again, just shy of when his knees, or when his heel is completely level. Because part of what I want to check is his lower leg rotation. We already spoke about earlier that when his heel struck relative to where his heel recovers, it was slightly rotated. So part of what we want to do now is kind of assess that rotation. So I'll do another setup. This time my axis of rotation of this kind of electrogoniometer goes middle of the knee. This arm lines up with the middle of the calcaneus. Again, I'll zoom in just to make sure my points are correct, and I'll change the color again to yellow. I should just make this standard, but apparently there's no option for that. Then I want the other arm to kind of line up with the mid glute. I will then, you can see that it says 247. I'm interested on this inside angle here, so I'll just invert that angle, so 112. Again, my goal here is to have 180 degrees, meaning that this heel should be tracking completely underneath this glute. We're off by quite a bit, so we'll want to look at what might be causing this rotation. So again, it will be a hamstring adductor type of an issue that we'll want to look at in a little bit more detail in our analysis. So again, I would screen capture this. I'm not going to do it now. You'll get the general gist of what it is we're doing. Again, this should be 180 degrees, meaning this heel needs to track a lot more laterally in order for him to be more efficient when it comes to his running. This may lead to instability issues a little bit later on. Okay, while we're on this, I will delete this section, and part of what we'll want to look at is when he's in mid-stride of his stance phase. I want to look at what his foot rotation is. This one's a little bit more tricky. I'll need an extra little bit of help in order to do this. So what I'll do is look at image, and I'll put a grid on that just helps to give me some level straight lines in order to assess the angle of the foot. So this is what's called medial heel whip. You can see that the heel tends to whip medially towards the midline, meaning that the toes are more laterally. This is completely normal. It tends to happen if I just look at this other foot. As the foot tends to strike, right, there's a certain amount of pronation that happens. When I have foot pronation, there's a certain amount of tibial internal rotation that tends to happen. And the only time that that can be released is as the person toes off and recovers. It tends to counterbalance. So the heel will tend to whip medially, and a normal amount is about 5 degrees. So part of what we'll want to do is to see exactly how much that is. So the long axis I will align with the longest part of his foot. The movable arm I will want to, with the axis of the goniometer, I will want to align on the mid part of his calcaneus, and then this other arm must be completely level. That's one of the reasons why I use this grid, to make sure that it's a nice straight line. I'm happy with that, and I'm going to invert this angle again. You can see there that's 14 degrees of heel whip. Like I was saying, normal you're looking at about 5 to maximally 8 to 10, not more than that. So here's quite a bit of medial heel whip. Again, I would screen capture this and use it in my reports for further analysis. Okay, good. Alright, so then I can delete this again. I will hide the grid. The next part that I'd want to look at, since we're still assessing and analyzing the right foot and the right side, I want to see what is happening in terms of hip stability as he is loading that right side. So part of what I want to look now is how much pelvic drop is he experiencing. So again, I would try and just use a perspective grid in order to give me a little bit more accuracy. Okay, so I can see his hips are here. I want to try and make some kind of note of where his trochanter is. So again, wrong one. Need the angle measure. Okay, so again, I would need a level line. So I want to make sure that that's really nice and straight. Not quite happy with that yet. There we go. That's nice and level. I'm going to try and align it with his greater trochanter, and then I'm going to swivel this around and try and see what his amount of tilting is on this specific side. So you can see here that's approximately 1 degree. Again, 5 degrees is relatively normal, so there's not much pelvic tilting. Good stability when it comes to this particular hip complex. Okay, so again, I would screen capture that, make a note of it, and use it in the reports. For now, I can delete and delete this as well. So then the last thing I want to try and check is how much upper body compensation there is as a consequence of this hip being loaded. So even though the hip is stable, because of the amount of rotation that tends to happen here in the lower leg and the fact that we've got some calcaneal eversion, it may mean that this loading is having an effect in terms of where his hip tends to shift. And we can tell just by his arm angles how far it is from his spine, for example, is something that you'd want to start looking at. So there's quite a significant distance relative to the other side, meaning that his elbow is tracked a little bit further from his midline than this particular elbow is when it's tracking. And part of why we're interested in that is it's usually a sign of compensation. In other words, if his hip is shifting out laterally, that this arm will move more laterally in the contralateral direction in order to maintain equilibrium as his body's being loaded. Okay. Again, it's always important to compare right side to left side, so that's what we're going to do now, is to try and just see how does his left side compare. So again, same exact process. What we're going to do is to assess where this heel, again mid-heel, strikes relative to where his mid-glute is. Right, and again you can see his hip is shifted out a little bit out to the side relative to where the heel tends to strike. I'll play a few frames forward just to see where his heel recovers. So when you look at this, again mid-heel, right, almost perfectly in line. Okay, so this is a much better heel tracking than it was on the right side. So again, I would screen capture this, and then it allows you to do left side, right side comparisons. Okay, so I'll just go delete these so long. I'll play a few frames back just to see what his calcaneal angle is as he's loading this particular leg. Okay, remember you'll take the angle measure. Part of what you'll have to do is align the movable arm on the mid-calcaneus. Again, I'll zoom in as much as you possibly can. Make sure that it's definitely in the mid of the Achilles. This other movable arm is mid-calcaneus, and this movable arm is the middle of the knee. Okay, so you can see here this is about, we'll just invert that, 175 degrees. We said, remember, it's within 5 degrees is pretty normal, so this one is a little bit more stable again than it was on the right hand side. So screen capture this, use it for comparative purposes. Alright, zoom out again. We'll delete. The next part that we'll want to look at is that lower leg rotation, so just shy of that. Let's look at that angle. So again, mid of the axis of rotation, you do mid knee. So just zoom in, move this up a little bit. Just want to make sure that we hit the middle of the knee. This movable arm goes middle of the calcaneus, and this one is middle of the glute. Alright, so you can see this is, let's just invert these colors, just make this yellow. So I'm just trying to play it back a little bit. There we go. Alright, so he's sitting at around about 138 degrees. So again, our goal is to get this closer to 180 with plus or minus 5 degrees of play. So again, you can see that for this athlete, the amount of medial rotation or external rotation of the hip is being affected here quite a bit. So you'd want to look at his hip rotators, you'd want to look at his hamstrings, you'd want to look at his adductors and put a treatment in place, either focusing on releasing the rotators, increasing stability of the hip, releasing hamstrings, releasing adductors, and trying to do some kind of PNF mobilization triggering in his specific treatment. Okay, so we'll delete that. We've checked that. The other part that we want to look at is his medial heel whip. So again, we'll use the perspective grid, or just the normal grid, in order just to facilitate this process. Make sure that our lines are completely straight. So the axis goes on mid calcaneus, other arm goes, oopsie, wrong one. Okay, let me just delete that. I'm just going to try that again. Let's get the angle measure. So mid of the calcaneus, and this is the long axis of the foot, and this has to be a nice straight line, and then I will use a different color to make it nice and clear. Alright, so we said that again, normal is about 5 degrees to maximally 8 to 10, and again we're sitting at 13 degrees, which means that we have some rotational abnormality. So you have to start thinking about, well, what can be causing this. Remember, part of this is as a result of what's happening during stance. So it's already during stance that you need to be thinking about what is going to be causing consequences of this medial heel whip. Okay, so again, maybe stability issues, pronation issues, deep muscles of the lower leg issues that may need to be addressed. Okay, so again, I would screen capture this, compare left to right sides. And then the last thing that we need to do is just look at his pelvic drop on this side. So again, since we're assessing the left side, I have to look at what's happening during the stance of the left leg. Okay. So again, I would use my angle measure. Let me just undo that. I'll use the perspective, the grid again. Zoom in as much as I can. Use the angle measure. Again, my goal is to align. I need a straight line, and then align the other arm with the opposite trochanter. So let's just get that aligned. So again, we're looking at around about a 3-degree tilt, which is still well within acceptable norms. A little bit better stability. If you look at, again, this arm is a little bit closer than this arm was on the previous stance phase. Since this is still a basic evaluation, I'm not going to go into the actual distances, but we will be able to determine exactly how far this elbow is from the midline of the spine and give us some more objective numerical data in order to quantify exactly what that distance is. But for now, this is just an introduction. Again, I'm trying to screen capture this, compare left to right side in terms of stability. Okay, so once you've done that in your report, right, you do left side, right side comparisons. Okay, so for every component of what we've assessed and analyzed so far, you will have a picture that tends to compare this, and make sure that you have left side, right side comparisons and ratings that tend to go with it, and you'll want to write a general analysis of what your findings are and what your recommendations will be, as well as what treatments you used in order to correct the technique. So your goal is, once you've identified the factors that may be affecting his performance, you will use a treatment intervention that should take you approximately 30 to 40 minutes, and then you will reassess everything that you've done so far to see if there was an improvement or not, because that way you can see if your treatment or your intervention was effective and what your strategy should be going forward. I hope that's made sense, and yes, we'll see how that goes.